Hello, this is the Chapter 4 exam review. So we're going to go through all the different problems that you're going to see on the Chapter 4 test, and I'll try to explain how to do each one in some detail. So this is the first problem that you'll come across on the exam. Here we want to multiply these two expressions together. We don't have to use FOIL because we're not adding or subtracting in these parentheses. It's just one term times another term. So we multiply together what goes together. So we're going to take the negative 8 times 6, because those will multiply together. And we're going to take the x to the negative third power times x to the negative seventh power, because those will multiply together. All right. So negative 8 times 6 is negative 48. And we'll multiply these x's together, and the rule that governs this interaction is the base will stay the same, and we will add the exponents together. That's how we accomplish the multiplication. So we have negative 3 plus negative 7. That adds to give me negative 10. So that simplifies the expression, but there's one other thing we have to take care of. So whenever it asks you to simplify an exponential expression like this, there's really three things you need to take care of. We have one more thing left here, though. The three things you want to make sure you've accomplished is that you don't have any negative exponents, right? And that's the thing we have to deal with here. We have a negative exponent. One of each variable, so don't leave the expression with two different x's, multiply those together into one x, right? That's what we just did. And then simplify or reduce the numbers. So here we simplify the numbers by multiplying them together. So make sure before you submit your final answer on this problem that you've checked those three things off the list. It's not any particular order, but it's the three things that need to be accomplished. So we still need to deal with this negative exponent. So the way we deal with that is we make it a positive exponent by flipping it over, right? The negative 48 will not be part of that, right? The negative 48 is being raised to the first power. It doesn't need to be flipped over. So we leave the negative 48 where it's at, even though it's a negative number, the exponent's not negative. Just the x has a negative exponent, and we're going to flip that down to the bottom, right? So think of this as a fraction. We're going to take the x, flip that down to the bottom, and that'll make the exponent positive. So my final answer is going to have the negative 48 still on top, and then on the bottom, we'll have x. By flipping it over, it changes the sign of the exponent from negative 10 to positive 10. And this meets all the criteria. One of each variable, no negative exponents, and we simplified the numbers as much as we could. And so this is what your final answer should look like for that one. All right, let's take a look at the next problem. All right, so same set of rules. One of each variable, no negative exponents, and then simplify or reduce the numbers. Now, the order you want to tackle those in kind of depends on the way the problem's set up and your particular preferences. I personally don't like dealing with negative exponents here. It makes it more difficult, especially if you're dividing, because the rule for dividing is you'll subtract the exponents. And you could do that here, but when the exponents are negative and you're subtracting negative numbers, it can get very confusing, and a lot of students will make mistakes. So what I'd like to do first is I'm going to flip anything that has a negative exponent, I'm going to flip it over. And they both happen to be x in this case. So I'm going to flip this x up to the top. This x will get flipped down to the bottom. So I'll still have negative 15 on top. Then I'm going to bring x to the negative 8th power up here, and that'll make it a positive 8 when I flip it over like that. And then the y will stay in place. So I'll still have y to the 7th power. On the bottom, we'll have the negative 6 here. We flip this x down to the bottom, so now it will be x to the positive 5th power. And then the y we just left where it was, so it's going to be y to the 9th power. Right. Again, this is just my personal preference for how I like to complete this particular problem. There's definitely other ways you could have approached it. So now what I'll do is I'll go through each of these, simplifying, combining together, doing whatever I can do. So for example, we have a negative divided by a negative, so those will just cancel each other out. 15 divided by 6, we can reduce both of these by 3. So I'm going to divide a 3 out of both of these. And so that's going to become 5 on top, and we'll have 2 on the bottom. Right, 6 divided by 3 will be 2. We'll combine the x's together by subtracting the exponents. So the rule that governs this interaction is if you're dividing two things with the same base, you subtract the corresponding exponents. And you want to do this in a very precise way, at least I do, because I want to keep it as simple as possible. So I always do it this way. Top power minus bottom power, and then put the answer on top. So it's going to be 8 minus 5, which will be 3, and then the answer is going to go on top. So the base stays the same. 8 minus 5 is going to give me a positive 3. Put the answer in the numerator. I'll do the same thing with the y's, right? So we'll take top power, which is 7, minus bottom power, which is 9. And that's going to give me -2. So the base will stay the same. I'll still have y as my base. -2 is the exponent. When I subtract 7 minus 9, the answer goes on top. However, that does make it a negative exponent, and so we want to simplify that, and we'll do that by taking the thing with the negative exponent, flipping it back down to the bottom. Right. So again, there's other ways you could think about that situation, but this is the way that I like to approach it. So it's consistent, and it's simple and clear. Right. So bring the y down to the bottom. By doing that, we'll change the sign of the exponent from -2 to +2. And then this expression meets all the criteria that I mentioned at the beginning. One of each variable, there's no negative exponents, and we simplified and or reduced the numbers. All right, let's take a look at the next one. So here what we're going to do is, you could fret about the negative exponent here, but then when we apply this negative exponent here, it's going to change which ones are negative and which ones are positive anyways. And so you could end up, processing this negative exponent, then having this come in and making it negative again and having to undo what you just did, basically. You have to reverse it again. So I think the easiest way to approach this one is just to go ahead, even though it's a negative exponent, take this power of -3 and apply it to each factor inside the parentheses. So it's essentially distributing, right? And we're going to apply it not just to the variables, but also to the number here. So we're going to have -2 to the -3rd power. We'll have g to the -3rd power being raised to the -3rd power. And then we're going to have h to the 2nd power raised to the -3rd power. So it's going to look like this. Right, I'm going to use parentheses on each one of these. All right, so we have -2 to the -3rd power. G to the -3rd power is getting raised to the -3rd power. And then h to the 2nd power is getting raised to the -3rd power. Now here things kind of behave a little bit differently because it's different than what we were dealing with previously. Here we have one base that's being raised to 2 different powers. So whenever we have one base with 2 exponents acting on that one base, we multiply these exponents together. So we multiply here. We don't add, we multiply. Right? Contrast that with the first situation that we had, where we have 2 exponents here, but each one has its own base. Right? So if each exponent has its own base, when you multiply these together, you'll add the exponents. But when both exponents are already on the same base, you multiply. Right? So these will get multiplied together, and we'll get g to the +9 power. Right? -3 times -3 will be +9. And this will become h. Same thing's going to happen here. These will multiply, and we'll get h to the -6 power. Here, we really can't do anything with this yet, because when you have a negative exponent, you really cannot evaluate what this is equal to until you make that exponent positive. So I'm just going to copy this down. So I'll have -2 to the -3rd power still, and we'll figure that out in just a second. All right. Now, I don't want any negative exponent, so what I'm going to do is think of this as a fraction, and anything with a negative exponent gets flipped down to the bottom. So this thing right here, flip that down to the denominator. That'll make the exponent positive. This thing right here, we're going to flip down to the denominator, make that exponent positive. G already has a positive exponent, so we just leave it where it is. So we'll have g to the 9 on top, and on the bottom we'll have the 2 will still be negative. I can't do anything about negative numbers. I can only change negative exponents. So this exponent of -3 will become a +3. And this exponent of -6 will become a +6. But negative numbers, you're stuck with the negative sign. You can't make those go away by flipping it over. And so now we're going to evaluate this because we want to simplify the numbers here. So -2 to the 3rd power, now that it's a positive exponent, I can evaluate this. I just take -2 and multiply it to itself 3 times. And that's going to give me -8 when I do that. Right? Negative times a negative times a negative is negative. 2 times 2 times 2 is going to be 8. And so I'm going to get g to the 9th on top. We'll have -8 on the bottom, and then h to the 6th power. And this meets all the criteria, right? One of each variable, no negative exponents, and we simplified the number. All right, let's look at the next one. So what I would do with this one, again, there's different ways you can approach it, but I think what's easiest is to simplify the variables first, right? Instead of distributing this power of -5 to 6 different things here, it'll be easier if we just go ahead and reduce this fraction, combine the u's together, combine the v's together, then we'll have less things that the -5 has to apply to. In fact, once we do the simplification here, it'll look just like the last problem that we just did. So for example, the 25 and the 5, right, we can, well, I guess what I'll do is rewrite this problem, getting rid of the negative exponents first, because again, I don't like to subtract exponents that are negative. It's just too easy to make a mistake. So I'll flip both of these over to make them both positive. So we'll get 25, u to the second, v to the positive third when I flip this one up to the top. And on the bottom, I'll have 5, u to the sixth, v to the positive fourth when I flip that one down to the bottom. And then I'll simplify each of these. So 25 over 5 reduces to 5, right? It's like 25 divided by 5. That's going to be 5. For u, these have the same base, so we will subtract the exponents. We have to go in this order. 2 minus 6, which gives me -4. And then for v, we'll do the same thing. The base stays the same. We'll subtract in this order. 3 minus 4, which gives me -1. This is still being raised to the -5th power. I probably should have copied that down here. Right? This whole thing's still being raised to the -5th power. So I still have that here. And then now what I'll do is I'll distribute this power of -5, just like we did in the last example. Right? And so it'll apply not just to the variables, but it applies to the number as well. All right, so we're going to get 5 to the -5th power. Now here we can kind of take a shortcut. I did a little bit more writing here than I normally would do because I know what's going to happen. When this power of -3 gets distributed to these variables, it will multiply to the exponent that's already there. And you can kind of do that in your head, right? -3 times -3 is going to give me 9. So I don't need to write it like this first to know what the result's going to be. And so I'm going to try that here, right? So what's going to happen is this -5, when it applies to this variable, it'll multiply to the exponent that's already there. So I'm going to get -5 times -4, which is going to be +20. Right? So the base will stay the same. -5 times -4 is +20. And for v, it's going to be -1 times -5, which will be +5. Right? And so we can't leave our answer like this because we have a negative exponent here. So what I need to do is take this and flip it down to the denominator. So again, think of this as a fraction. Think of it as over 1. And what we're going to end up getting, the u will stay on top because it already has a positive exponent. V will stay on top for the same reason. And on the bottom, we'll get 5 to the 5th power. Now, at some point, as the exponents get bigger and bigger, like they have been, it stops making sense to multiply it out because the numbers get so massive that it's just simpler to leave it in exponent form. So I'm not sure, the directions aren't very clear with what I saved from the practice test. It's not clear if we should multiply this out or leave it as an exponent. I imagine where you type the answer in the box, it would have some more details for us, and I didn't copy that, so I apologize, I didn't have it on the screen. So this might be okay. I would look at the directions to see if that would be the case. If not, if it says to multiply out the numbers or to simplify the numbers specifically, you'd need to plug that in your calculator, 5 to the 5th power. I'm not even sure what that is off the top of my head. Let me see if I can find a calculator. All right, I think I found one here. So 5 to the 5th power is 3,125. So like I said, it kind of gets a little bit silly to write that number out because it becomes such a big number. But this would be another way to write the answer. Over 3,125 because that's what 5 to the 5th power is. So again, I would look at the directions carefully to see which version of this answer you would need to type in. Okay, let's take a look at the next problem. So I think we're going to be moving on to something else, I guess scientific notation here. So scientific notation is a way of taking a big number like this and writing it more compactly, especially when there's a bunch of zeros. We can take advantage of that to rewrite the number in a much more efficient way. And so what we do is we want to write it in this form, d times 10 to the n power. And the reason we use 10 here is because our numbering system is in base 10, right? Each place value is another power of 10. We have the ones place, we have the tens place, we have the hundreds place, which is 10 squared. We have the thousands place, which is 10 to the third power. So each place value is a power of 10. So all I need to do is count the place values here to figure out what the power of 10 should be on this number. And for the number that's out in front, we want this to be between 1 and 10. So between 1 and 10. Now, sometimes, I don't think you're going to come across this, but it's okay for it to equal 1, but it's not okay for it to equal 10. So if you have a 10 there, you can move the decimal place one more time to make it a 1, and that's what you would prefer, right? So what I'm going to do is move my decimal place, which is currently located right here, until I get a number between 1 and 10. And so to do that, I'll have to move it to the left. So we're going to move it 3, 6, 9, 12. If I stop there, I get 26.0. That's not between 1 and 10. So I got to go one more time, and that'd be 13 times, right? So I've moved the decimal place 13 times. That's 13 powers of 10, if you will, right? And so this number is going to become times 10 to the 13. And the number that'll be out in front is we're going to have 2.6 and then a bunch of zeros, which we can just drop because once it's in decimal form, those zeros don't really count anymore, right? So it's going to be 2.6, and then we drop the rest of the zeros. And so that gives us an easier way of writing that big number, right? So move the decimal place until it's between 1 and 10. Write that number over here, and then however many times you move the decimal place, that's the power that you want to use on the power of 10, right? Now, the other thing is sometimes the power should be positive, sometimes it should be negative. So the way I remember that is if it's a big number, like this one was, big, right, 26 trillion or whatever this one is, it should be a positive exponent. So it's going to be positive 13 like we have. If it's a small number, like 0.0000005, right, that's a really small number of something, then it'll be a negative exponent. Right. On the test, it could be either one. It's random. We happen to get one with a positive exponent, but when you take the test, it could be a negative exponent. So you need to be ready for either one of these. So if it's like 0.0000005, like I just said a moment ago, we follow the same process, move the decimal place until we get a number between 1 and 10. So 1, 2, 3, 4, 5, 6, and then we have to get on this side of 5 to get it between 1 and 10. Right, so that'd be 5, right, 5.0 times 10 to the, this time we move the decimal place 7 times. So that's the power I want on the 10, but because this is a small number, the exponent should be negative. And so this is the result. All right, so be ready for either of those cases. All right, so here we're being asked to factor. In Chapter 4, as you've gone through the homework, you have encountered many different kinds of factoring. And so you have to be ready for any of those, and all of those different types of factoring. The first kind of factoring that we learned was to identify and then factor out a greatest common factor. So we want to find the greatest common factor here. And the way you do that with the numbers, we have 2 and 6, is you want the biggest number that divides evenly into both of them. So the biggest number that divides both into 2 and into 6 would be the number 2. That's the greatest factor that those two numbers share in common. For the variable part, for the x and the y, what you want to do is take each variable factor that they share in common. They both have an x, so I want to have an x in my greatest common factor. And they both have a y, so I'm going to have a y in my greatest common factor. So only if they're shared in common with both of them, you should have them in your greatest common factor. So this time both variables are common to both of them. And this might seem a little bit backwards, but for the greatest common factor, you want to raise each variable to the lowest power that occurs, because that's the most that's shared in common, right? So if we saw, oh, we have x to the third power here, if I try to raise this to the third power, these two don't share that much in common, right? This has 3 powers of x, this one doesn't. So what we're constructing here is what they share in common. What's the most that they actually share in common? And the most they're going to share in common is 2 powers of x. So whatever the lower number is, that's the most that's shared in common. They both have 2 powers of x. They share that in common. They do not both have 3 powers of x. They don't share that much in common. So the same thing with the y's, right? How much do they both share in common? What's the most they share in common? It's 4. the lowest power of y is the most that's shared in common between these two. All right, so that's my greatest common factor. That's how you construct that. That's how you find it. Once you've identified the greatest common factor, what you're going to do is you're going to factor it out. So you start by writing it out in front, and then in a set of parentheses, you're going to write what's left over when you take the greatest common factor away from each of these terms. You are essentially undistributing the greatest common factor. It's the distributive property, but in reverse. We're taking it away and putting it outside parentheses. So if I take the 2 away from this first term, because I'm taking a 2 away, there won't be a 2 left. I'm taking away 2 powers of x. This term has 3 powers, so I'm going to have 1 left over. Right? There was 3 to begin with. I'm taking away 2, so we're down to having just 1 power of x left. We're starting with 4 powers of y. I'm taking away all 4 powers of y, so this term will not have any powers of y left. So all that's going to remain for this first term is just 1 power of x. And then we'll have the minus sign because that's what's in the expression. We're going to take a 2 away from the 6. Now when I say take away, I know that sounds like subtraction, but what I'm really doing is I'm taking away a factor of 2. So if I think of 6 as 2 times 3, I'm taking this 2 away, so there's a 3 left. So really what's happening is you're dividing. I'm going to take the 6, divide away a 2, I'll have a 3 left over. I'm taking away both powers of x, so there won't be any x's left, and I'm taking away 4 powers of y. There's 5 here to begin with, I'm taking away 4, and so there'll be 1 power of y left over in the parentheses. And so this is factoring out the greatest common factor. It's really important to get the hang of that because it will continue to happen for the rest of the chapter, as you probably have noticed if you already are getting ready to take the test. So you always want to look for a greatest common factor, and you always want to factor it out if there is one. All right, let's take a look at the next problem. Factor by grouping is another technique for factoring. You should be aware of, or I should say be alert about applying this technique when there are 4 terms in your polynomial, right? So we have 1, 2, 3, 4 terms in this polynomial. So factor by grouping is the only technique we have for dealing with that situation. So when I see 4 terms, I'm automatically thinking I'm going to have to do factor by grouping. The way factor by grouping works is you artificially group the first 2 terms together by using parentheses around them. Right? So that groups the first 2 terms. And then you group the second 2 terms together. So that would be the 2x and the minus 14. And then you have this minus sign here, which a lot of students mistakenly put in between the 2 groups, but that's not where it should go. It should stay with the 2x inside the second group. So it should go here. And my advice to my students is always start with a plus sign between your 2 groups. That's the safest way to get things set up. Right? And then what you do is you factor out the common factor in each group. So the common factor in the first group, what do these share in common? Well, they don't share any numbers in common because this one has a 7, but this one doesn't. They do both have an x. The lowest power of x is x to the second power. So that's the greatest common factor is x squared. So I'm going to take that away from both of these terms. This will have 1 power of x left over, plus I'm taking away x squared from this, so only a 7 will be left over here. All right, so take away 2 powers of x from both of these. This is what's left over. And the thing you're factoring out goes out in front of that parentheses. Here, the common factor, they don't share any variables in common, so there won't be any variables in my common factor, but we do have some numbers here. We have a 2 and we have a 14. The greatest common factor of 2 and 14 would be 2. Now, if that's all I factored out, I would have a negative x left over minus 7, and then this would still be a plus sign here. The problem with that is that we cannot take the last step in this process if this is how we write it. Because in order to take the last step in the process, the leftover part here, the parentheses here, has to match to the parentheses here. These two need to come out the same in order for factor by grouping to work. If these don't exactly match each other, you cannot finish this problem. So they're not matching right now, so we're kind of stuck. But we can get them to match because they're really close. The only difference is the signs, right? So I can change the sign of both of these if I factor out a negative with the 2. That'll switch this to positive x, switch this to positive 7, then it's going to match up to this. So let me just rewrite the problem. We have x squared times x plus 7. But this time I'm going to factor out a negative 2, a negative sign with a 2. That's going to leave me with a positive x and a positive 7 in the parentheses. Now these match each other. And so what's happening here is we're doing greatest common factor again, right? I have these two terms. I have this term here and I have this term here. And this is the factor that they share in common. This one has an x plus 7. This one has an x plus 7. That's the greatest common factor. So I'm going to factor it out. I'm going to undistribute it. So I'm going to write the greatest common factor one time in front, x plus 7. And then in a new set of parentheses, I write what's left over when I take that away. So when I take away the x plus 7, I'll have an x squared left over in the first term. And when I take away this x plus 7, I'll have a minus 2 left over for the second term. And now this is factored. Okay, because now we have two things being multiplied together. Right, let's take a look at the next one. Factor this trinomial. So whenever a is equal to 1, which is the case here, right? There's a 1 in front of the t squared. That's our value for a. We can use what I call the shortcut method for factoring, which is to find two numbers that multiply to c and add to b. C in this case is equal to 6. B is equal to negative 5. So c is equal to 6. B is negative 5. And so we want to find two numbers that multiply to 6 and add to negative 5. Be careful with 6 and 5 because there's kind of two ways to generate a 5. You could either have 6 and 1 or you could have 3 and 2, right? Both of those multiply to 6. What makes the difference there is what signs you need to have. So in order for us to get positive 6 when we multiply, but negative 5 when we add, what we're going to have to do is use negative 3 and negative 2. Right? Negative 3 times negative 2 is positive 6. Negative 3 plus negative 2 is negative 5. So those are the two numbers we're looking for. So that's step 2. Right? Step 1, find c and b. Step 2, find two numbers that multiply to c but add to b. And then step 3 is this is the shortcut. You just get your answer from that. It'll factor as the variable plus the first number, which is minus 3, times the variable plus the second number, which is minus 2. So these two numbers are just going to show up in your two factors with the variable. And it's a shortcut that just happens to work when a is equal to 1. All right, so that's how that one's going to factor. Let's take a look at this one. So here, initially, we cannot use the shortcut because we have a 2 here for a. But don't give up hope just yet. The first thing you want to do with any factoring problem is factor out the common factor. And if you look, each of these numbers is an even number, which means we can factor out a 2. All right, so I'm going to factor out the common factor of 2, and that's going to leave me with y squared minus 4y minus 6. And this, it looks like we can't do anything else with this. So this is kind of interesting. I wasn't expecting this. Let me make sure I have done. No, I messed up, didn't I? Okay. I was going to say, like, this would not factor any further because we have to find two numbers that multiply to negative 6, add to negative 4. However, I shouldn't have negative 6 there. I don't know what I was thinking. I guess that 4 threw me off. I'm factoring out a 2. So 24 divided by 2 means I should have a 12 here, not a 6. So I apologize for that. And this is more what I was expecting. So now that we've factored out the common factor, the part that's left over can be factored the same way as the last example. A is equal to 1 here, so we can use the shortcut. C is equal to negative 12. B is equal to negative 4. So we need to find two numbers that multiply to negative 12, add to negative 4. That'll be negative 6 and positive 2. Right. That multiplies to negative 12, but when I add those together, I get negative 4. And the shortcut is, these are the two numbers that are going to be in my two factors. So I'll have y minus 6 and then y plus 2, right? Negative 6, so I put minus 6 here, positive 2, so I put plus 2. And then don't forget, this is really important on the test because, you know, Math Excel doesn't give partial credit. So if all you type in is y minus 6 times y plus 2, that's not exactly completely correct because you had a common factor of 2 that should be part of your answer as well. So make sure you copy that down, and then this is what you type in to Math Excel to get full credit on the test and on the homework. All right. Now this one, the variables have a little bit of a higher power. The official way we're supposed to deal with this is to rewrite this by substituting in a new variable to replace the old one to make it look more like what we're used to dealing with. Right? So this is what we're used to dealing with here. ax squared plus bx plus c. That's what I want this problem to look like, because if it looks like this, I know how to factor it. And it looks pretty close, right? It's 3 terms, but instead of w to the 4th power, what I'd like to have there is x squared. And instead of w squared, I just want to have an x there. And you can't just assume that it automatically fits that structure. You want to check to make sure that it does. So what we could do to make this problem look more like this is we'll just replace. We'll just cover up this w squared with an x. Right? The 81 will still be there. The plus 80, I'm not going to mess with that, so I'll just copy that down. The million-dollar question here is, if I make this choice to replace w squared with x, is it okay? Question mark. Is it okay for w to the 4th power to be replaced by x squared? Because if that's okay, then I'm in business. I can factor this. If that's not okay, then I'm not going to know how to factor it. So we want to double check here if that's going to be okay. And the way you check that, there's a couple ways you could look at it. I guess the easiest way is to think of it this way. Let's rewrite the w to the 4th power as something squared, because that's what I want to have here, is something squared. W to the 4th power would be w squared to the 2nd power, right? Because those exponents would multiply together. So I can rewrite w to the 4th power as w squared to the 2nd power. And then just like I did over here, I will replace the w squared with an x. And then that power of 2 just copies down, and so I end up with x squared. Same thing I did here, right? I replaced the w squared with an x. So as long as you're consistent and x is taking the place of the same thing in both cases, that's the important part. Now that I've got it in the right form, I know how to factor this. I need to find 2 numbers that multiply to 80, but add to 81. So this is kind of a, this one comes up pretty frequently. When it's just one bigger than the thing you're trying to multiply to, it's always that number and 1, right? 80 times 1 is 80. 80 plus 1 is 81. The shortcut tells me this will factor as x plus 80 times x plus 1. If this is what you type in on your test for your answer, or in your homework for your answer, MathXL is not going to count this correct, because MathXL doesn't know what x is. It didn't have x in the problem, so it doesn't even recognize that variable, because the only variable it's going to recognize is a w. So what we have to do is, once we're done with x, we have to take the x back out of the problem and put back in the w squared, right? So underneath this x is a w squared. Underneath this x is a w squared. So take the x back out, put the w squared back in to get the final answer in the original variable that was given in the problem. So same thing here. Replace this x with a w squared, and then the plus 1 just copies down. All right. And that's going to be our final answer there. Now, a lot of students don't bother with the substitution aspect of this. They just recognize, well, it looks just like the other problem, so I'm going to factor it in the same way. And then they just kind of trial and error figure out what the variable should look like. Should it be w? Should it be w squared? Should it be w to the 3rd power? To make sure that it matches up to this. So kind of trial and error, just making sure that if you multiply this back out, you get w to the 4th power here and w squared here. So that's fine if you want to do it that way. Gets you the same answer either way. All right. So let's take a look at this one. So here, this is our first example where we cannot use that shortcut that we've been using so far. Because here, a is not equal to 1, a is equal to 3, and c is equal to 5, and b is equal to 16, right? And so here, there's 2 methods we could use, but I'm just going to illustrate one on this video. We could do trial and error, right, where we guess what we think the answer could look like. So we kind of set it up like this, and we say, okay, we expect the answer to look something like this. Now, how can I get 3b squared? Well, to get 3b squared, I probably would have to have a 3b in the first parentheses and the b in the second parentheses. And then when you FOIL, 3b times b gives you 3b squared. So you could approach it that way, right? Just by kind of guessing what you think the answer should look like, and then checking your guess. You can't just assume your guess is right. You have to check it by FOILing it out to make sure it matches up to all 3 of these terms here. So that's one method you could use, which, like I said, I'm not going to completely illustrate. The other method, which I like better because it's a step-by-step process, is called the AC method. So the first step is to multiply a times c. In this case, that's going to be 3 times 5, which is 15. The second step is, and this is pretty similar to what we were just doing, find two numbers that multiply to AC, which is 15, and then add to B, which is 16. So two numbers that multiply to 15, add to 16, that's going to be 15 and 1. Right? 15 times 1 is 15, 15 plus 1 is 16. But here's where it differs. So we can't take a shortcut and just get our answer on these numbers. We can't say, oh, the answer is B plus 15, B plus 1. What we have to do instead, and this is step 3, okay, I must be pushing the button here, is to rewrite the middle term. Right? So we have 3b squared plus 16b plus 5. We're going to rewrite this middle term using these two numbers. So I'm going to rewrite the 16b as 15b plus 1b. So that's how those two numbers get used in the problem. So it's still the same expression. I'm just writing it in a different way. I'm writing the 16b a little bit differently. And what this does for me is it gives me 4 terms. And as I mentioned earlier, when you have 4 terms, the method that you should consider is factor by grouping. So I'll group the first 2 terms together, group the second 2 terms together, and then factor out the common factor in each group. Go through the factor by grouping process. So the common factor here is going to be 3b. That's going to leave me with a b plus 5. The second group actually doesn't have a common factor. It's just going to stay the same. So we have 1b, which is just b, plus 5. Right? And that's okay because the important thing is that the parentheses match up to each other, which they do. So I'm going to factor that out. I'll have a b plus 5 in front. I write it one time out in front. And then in a new set of parentheses, I write what's left over, which is a 3b from the first term, plus there's nothing left over here, so it leaves a 1 behind. There's sort of an invisible 1 here, if you will. So when we take away the b plus 5, the 1's not invisible anymore. We have to write the 1 there. And so that would be how this one factors. And that's using the AC method. You would come up with the same answer here eventually. You might do some different guesses first, but eventually you would stumble across this as one of your guesses, hopefully. And then that would give you the answer that way. All right. Okay, so this one is going to be the same situation, except the first thing we should always try to do, I forget to mention it when it's not applicable because my mind just kind of mentally checks it off the list before I even think to say something about it. But the first thing we should always do on these problems is look for a common factor. Right? This one doesn't have a common factor, so I didn't even think to mention it. This one, though, does have a common factor. Right? They all 3 have a v, so we could factor out a v. And it looks like the numbers are all even, so I know I can at least factor out a 2, maybe even more. But I think 2 is going to be the limit here. So I'm going to factor out a 2 and a v. And another thing that I don't like when I'm trying to factor is for this first term to be negative. I just find it makes me more likely to make a mistake. So I want this term to come out positive when I go to take my next step. So I'm going to factor out a negative with my common factor. That'll switch this first term to a positive, and it'll just go more smoothly having that be positive. All right, so factor out a negative 2. That's going to leave me with 25, and then v squared, right? Because I'm going to take away a power of v. This will also switch sign because we're factoring out a negative, so it becomes plus. This will become 10 when we divide that by 2. Take away a power of v, so we go down to v to the first power. This will switch sign because we're factoring out a negative, so it'll be minus. Divide that by 2, we get 24. Take away the v, there's no v's left here. Right, so this is what we end up with. Okay, so you factor out the common factor, and then this thing we want to try to factor even more. And so we're going to do the AC method again, right? So a times c in this case is going to be, this is kind of makes me cringe a little bit, 25 times negative 24, which is going to be a big number, right? Big enough that I need to find my calculator again. So 25 times 24 is 600, and it'll be negative because it's positive times a negative, which is negative. All right. B is equal to 10. So I am on a mission here to find two numbers that multiply to negative 600 and add to 10. And so I don't know what it is off the top of my head, honestly. I didn't work these problems out ahead of time. So if you have a big number like that and you can't think of the two numbers you're looking for off the top of your head, what you might have to do, and it's kind of unfortunate with 600 because I think it's going to have a lot of factors, but what I do is I make a list. What are the pairs of numbers that multiply to 600? And I start with the obvious, even though it's obviously not what I'm looking for. 1 times 600, right? That multiplies to 600, but that's not going to add up to 10. We have 2 and 300, right? We have 3 and 200, right? And so obviously we're not anywhere near 10, but we want to be thorough. We don't want to skip over any because we might skip over the one we're looking for. So we have 4, I think that would work, 4 and 150. We'll have 5 and 120, 6 and 100. I don't think 7's going to work. 8, does 8 work? Let's find out. I'll use my calculator. So I'll do 600 divided by 8, which is 75. So 8 works, but that doesn't add up to 10. All right, and so we'll try 9. No, 9's not going to work, I don't think. 10 would work. 10 and 60. And so we will go so on and so forth. I think 12 is going to work. It'd be 12 and 50. We're getting closer to 10, but still kind of far away. I don't think 13 works. I don't think 14 works. I'm going to skip up to 15. 15 and 40. I don't think that's going to work. So 16, let's try that just to make sure. I don't think 16 works. Nope, 16 doesn't divide evenly. 17 probably isn't going to work. I don't think 18 works, but let's just check. No, 18 doesn't work. 19 I don't think would work. What about 20? 20 and 30. There you go. Right now 20 plus 30 adds up to 50, but 20 minus 30 would give me 10. And so if one of them's negative and one of them's positive, when I add it together, they really subtract each other, and I'll get 10 that way. And that's exactly what we want because we want these to multiply to give me a negative. So this will be positive 30 and negative 20. Right? That multiplies to negative 600, but when I add those together, 30 plus negative 20, that adds up to positive 10. So sometimes you might have to just bite the bullet, start making a list of the numbers that multiply to AC until you find the one that adds up to B. All right. And so the next step, step 3, is to rewrite the middle term using these two numbers. I'm going to rewrite 10V as 30V minus 20V. The 25 squared gets copied down. The minus 24 gets copied down. And then I do factor by grouping. Right? So I'm going to group the first two terms together. We'll have 25V squared plus 30V. Sorry, it's supposed to be a V there. Always start with a plus sign between your two groups, and then we'll have the minus sign with the 20V inside the second group, minus 24. And then we do common factor for each of these groups, so I can factor out a 5 and a V from this first group, and I'll have 5V plus 6 left over. Here I will factor out a common factor, which is 4, but also a negative sign, because I want to switch the sign of these two to make them both positive, so it can match up to this. And so I'll factor out a negative 4, and that'll leave me with positive 5V and positive 6. Because these two are the same, I can factor out the 5V plus 6, and that leaves me with 5V minus 4. And then, as always, don't forget your common factor that you had from the beginning. You need to copy that down to your final answer. Notice that I did not bring that along as I went through this work because it's so easy for this minus 2V to get in the way of the factor by grouping. And you don't want it to be part of this process. It needs to stay separate. The best way to keep it separate is just to not write it there and just make sure at the very end to go back and grab that information and put it in your answer. All right, so that was kind of a tough one. Hopefully these will go a little bit faster because we're kind of, again, I like to keep my videos close to an hour, and I'm kind of worried about this one. I don't know how many more pages I have left. So this one, we could do the same way. We could do AC method. It works fine. In fact, I might even recommend that for this problem, as opposed to the way you're supposed to do it, which is to use this formula, a squared plus 2ab plus b squared. So if you notice that your first term is composed of squares and your last term is composed of squares, then there's a good chance this formula can be applied. So for example, the 9, we can write that as 3 squared. And the 4a squared, you have to write it as one thing to the second power. So this is going to be 2a to the second power, right? 2 squared gives me the 4. A squared gives you a squared. And so we have the first term is a square, the last term is a square, just like this formula. And so if it fits this formula, then we can memorize the answer to this situation. This will factor as a plus b squared. So it factors in this really nice way. That we can memorize. And so it'll save us time if we recognize that this formula applies. But instead of A in my problem, I have 2A. And instead of B, I have 3. So I have to make that same substitution in my answer. Instead of A, I should have 2a, just like I have over here. And instead of b, I should have 3, just like I have over here. So whatever is different in your problem on the left-hand side, you need to make those same changes to your answer on the right-hand side to get the answer for the problem that you were given. Now, really, I should double check to make sure that the 12a matches up to the 2ab. The way you check that is you take whatever you have here for a and whatever you have here for b and plug it in to make sure that it matches up to 12a. So I have the 2, and then instead of a, I have a 2a in my problem. Instead of b, I have a 3. And when you multiply those together, it should match up to the middle term in your problem. As long as that happens, the formula is safe to use. So 2 times 2 is 4, times 3, that's going to be 12. The a copies down. So I get 12a just like I have in my problem, which means the formula fits perfectly with the problem that I was given, which means the answer I'm getting from my formula is the correct answer. Right. So everything else copies down. So instead of a, we have 2a. Instead of b, we have 3. We're going to add those together, and then the square copies down. So that's how this will factor. Right. So this will factor like this. All right. You could also just do AC method if you found that confusing. All right. I should say there is a similar formula. I guess we'll see it right here, actually. So here, like we should always do, I keep forgetting to mention it, but factor out the common factor, and I'm expecting one here. So 3 looks like we could factor that out. We'll get s squared minus 8s, and then 48 divided by 3, you might need to use a calculator, but I have a pretty good feeling it's going to be 16. And so again, this will fit a formula. This formula is slightly different. It's a squared minus 2ab plus b squared, because our middle term is negative. And this will factor as a minus b to the second power. But instead of a, right, I have a in my formula. That's the one I have memorized. But in the problem I was given, instead of a, I have an s. And instead of b, I have not 16, because a lot of students will kind of fall for that trick. It's whatever squared here. That's what b is equal to. So we have to rethink this 16 as something squared. 16 is 4 squared. And so instead of b, I have a 4. Now I should double check that the middle term is going to match up to this, right? So I'll take negative 2 times, instead of a, I have s, and instead of b, I have 4. And let's multiply that out to make sure it matches up to the middle term I have here. And it does, right? Negative 2 times 4 will be negative 8. The s just gets copied down. It matches my middle term, which means the formula here is a perfect fit. And so I can use it to get my answer. Instead of a, I will have s, and instead of b, I will have 4. And everything else just copies down, and that'll be my answer, except I made the mistake I was cautioning you guys about, that when I type this into Math Excel, don't forget your common factor, right? So the formula gives me this, so this will factor as s minus 4 squared, but then the common factor of 3 should copy down, and so actually this is what I should be putting a box around. That's what I would want to type into Math Excel. All right, but again, you could factor this using the shortcut method, because a is equal to 1 here. Two numbers that multiply to 16 and add to negative 8 would be negative 4 and negative 4, which you can write as s minus 4 squared, right? So you'd factor this using the shortcut method. You get s minus 4 times s minus 4, because those are the two numbers that multiply to 16 and add to negative 8. And then you can rewrite that using exponents, right? S minus 4 squared. So you could also use that method instead of using the formula. Right. Here, factor out the common factor, which will be 8v, and that leaves me with q to the 4th power minus m to the 4th power. Now this one has a different formula that applies here, and this one you really need to use. The other two are kind of optional. You can just do it the old way that we were doing the previous examples, but this one doesn't really lend itself to those previous methods. So really the best way to do this problem is to use the formula. And the formula that it applies here is a squared minus b squared. This will factor as a plus b times a minus b. All right, so as long as the first term is a square and the second term is a square, and you're subtracting those two terms, we can use this formula to get our answer. In this case, these are to the 4th power, but I can rewrite these as things being squared. So I can rewrite q to the 4th power as q squared to the 2nd power. And I can rewrite m to the 4th power as m squared to the 2nd power, right? Because again, those would multiply back to 4. And so instead of a squared, I have q squared being squared, right? So instead of a, I have this being squared, and instead of b, I have this being squared. And so I'll make the same substitutions on the right-hand side of this formula. Instead of a, I'll have q squared plus, instead of b, I'll have m squared. And you do the same thing in the second factor. Instead of a, I'll have q squared. Instead of b, I was about to put b again. Instead of b, I will have m squared. Right. And then we have our common factor here. Let's not forget that. So I'm going to copy that over here. So we have the 8v. And so that's good. You did quite a bit of factoring, but the thing with factoring is you never want to stop until you've factored everything that can be factored. And in this problem, the q squared minus m squared can be factored again, right? Because this again fits into this formula. Instead of a, we have q, and instead of b, we have m. And so we can factor this one more time using the same formula that we just used. This one does not factor again because we're adding. And so if you're adding the two terms, this formula doesn't apply. And in fact, it turns out that this can't be factored any further. So unless there's a common factor, there's nothing else you can do with this. And so we're just going to copy it down. Right? So if you're adding these two squares, you can't factor it. You just copy it down. But if you're subtracting the two squares, that can be factored using this formula right here. And so we'll do the same thing again. Instead of a, we're going to have q plus, instead of b, we'll have m. And I'm running out of room here, and do the same thing for the second factor. Instead of a, we'll have q, and instead of b, we'll have m. And so this is how it's going to factor, and we've factored as much as we can. Nothing else here can be factored any further. All right, very good. Next example. This one factors also using a formula. So if you're trying to factor something with just two terms, essentially there's a formula made for that situation. This time though, it's not the one we were just using because this is being raised to the third power. So there's a different formula here. It's a to the third power plus b to the third power. And this will factor as a plus b, that'll be your first factor. And then the second factor is going to be a squared minus ab plus b squared. And so this is the one we want to use for this problem because we're adding these two together. So it turns out when it's cubes, when it's to the third power, adding is doable, right? We can factor something when we're adding. Let's see if I can do the arrow. I'm terrible at doing arrows. That's bugging me. Okay, let's see. That's a little bit better. Okay, there is a very similar formula to this if you're subtracting. It's a to the third power minus b to the third power. And it's going to look exactly like this except for a couple of sign changes. So for the first factor, instead of a plus b, it'll be a minus b. So the way I remember this is that whatever I'm doing in the problem is what I do in the first factor. So if I'm adding in the problem, I add in the first factor. If I'm subtracting in the problem, I subtract in the first factor. For the second factor, it always starts off with a squared, and then I switch to the other sign for this term. So if I'm subtracting here, this one will become adding. If I'm adding here, this one becomes subtracting. And it'll still be AB, that stays the same. And then the b squared is always positive. It'll always be plus b squared. That's the same for both of them. So that's how I remember the two formulas. So this is the one that we want to use here, but we have to figure out what we have here instead of a and what we have here instead of b in order to use the formula. So I need to rewrite both of these as something to the third power. Excuse me. And so for this one, 27 is 3 to the third power. And to get v to the third power, I just need a v here. So 3v to the third power matches up to this. And for 1, that's kind of a nice number because that fits into anything. It's 1 squared, it's 1 to the third power, it's 1 to the fourth power. And so to rewrite 1 as something to the third power, it'll just be 1 to the third power. Right? And so this is the thing I have instead of a. This is the thing I have instead of b. And so I take these substitutions to the right-hand side of this formula. Right, so instead of a, I'm going to have 3v, just like I have over here. And instead of b, I'll have 1. And we're going to add those two together, right? So in my problem, instead of a, I have 3v. Instead of b, I have 1. So I make the same changes to the right-hand side of this formula. Instead of a, I have 3v. Instead of b, I'm going to have 1. Here's where it gets a little bit tricky. Here, instead of a, I will have 3v. But that has to get squared. right? Because we're squaring that. Minus, instead of this a, I will have 3v. Instead of this b, I'm going to have a 1, right? So again, we're making the same substitutions here. Instead of this b, we're going to have a 1, plus, in place of this b, we're going to have a 1, and then that's going to get squared also. And the thing we have to be careful about here is when I square this, I don't just square the v, I square everything that a was equal to. So the 3 and the v are both getting squared. So we have to distribute it. And so we're going to end up with 9v squared here. Minus 3v times 1 is just going to be 3v, plus 1 squared is going to be 1. So you have to simplify this factor. Go ahead and square and multiply these things together to simplify it before you type it in as your answer on Math Excel. This factor should be ready to go, right? It's already simple enough, right? And so this is how this problem will factor using that formula. All right. So here we're going to come into some problems where we have to factor, and we're going to have to be creative and just try different kinds of factoring depending on what the situation is. So it's sort of, this is section 4.7 where it's miscellaneous types of factoring. And so you just have to be prepared for, it could be anything, right? So here, like I said, for every factoring problem, the first thing we should always look for is a common factor. And I notice here that these are all even. So I'll factor out a 2 first. I'll get v to the third power plus factoring out a 2 from this, we'll get 3v squared. Factoring out a 2 here, we'll have minus 4v. Factoring out a 2 there, we'll get 12. All right. And then because there's 4 terms here, remember the method we want to use when there's 4 terms is factor by grouping. So I'm going to group the first 2 terms together, put a plus sign between my 2 groups, and then group the second 2 terms together. That minus sign will stay with the 4 inside the second group. Leave the 2 out of the way, right? It's just going to get in the way when I do the factor by grouping, and it shouldn't get in the way. It shouldn't be part of that. So we just need to keep it separate. So I'll just not write it down for the moment. And then once I get my factor by grouping done, then I'll bring it back. All right. Common factor in the first group is v squared. That's going to leave me with v plus 3. Common factor in the second group is a negative 4, right? We want to factor out a negative with the common factor. So it leaves me with also a v plus 3. That's the important detail for factor by grouping, is that these 2 things match up. So now I can factor out that v plus 3, and that'll leave me with v squared minus 4. I have a v squared left over in this term, minus 4 left over in this term. Now that I'm done with factor by grouping, it's safe for me to bring the 2 back into the picture. And while you might feel like, well, we've kind of done this before, and I kind of, it might feel similar to what we've just done previously, we're actually not done with this problem because there's one more thing we can do to factor this. So remember, with factoring, you just want to keep going as much as you can. This v squared minus 4 fits the a squared minus b squared formula. So we can factor that as a plus b times a minus b, right? So this can be factored down even further. So let's go ahead and do that. We'll still have the 2. We'll still have the v plus 3. Instead of a here, we have b, so we're going to have v. And instead of b, we have, this is 2 squared. So instead of b, we'll have 2. So we're going to get v plus 2 and then v minus 2. So once you've used this formula enough times, you'll get enough practice with it that you'll kind of figure out these answers more and more quickly as you see this situation over and over and over, which if you haven't already, you will, because in chapter 5, we're going to run into that kind of factoring again quite a bit. All right. So, and also I'm trying to kind of keep this under an hour, and I'm hitting the 60-minute mark now, and I probably have a couple more problems left to look at. So I want to kind of hurry things up a little bit. So hopefully that made sense. This one is really tough. There's really no way I would expect any student to figure this one out without having been shown first. So if you're just trying to figure this out on the test, good luck to you, because it is tricky. It would be hard to figure out. You really kind of need to know how to do this going into the test. It's 4 terms, right? There's no common factor to all 4 of them. It's 4 terms, so we actually are going to do factor by grouping, but it's not the usual factor by grouping. We're not going to group the first 2, group the second 2. What we're going to do instead is leave the c squared as one of my groups, and then start with a plus sign, and then group the next 3 terms together. Negative d squared minus 10d minus 25. Now you might say, why would you even think to do something like that? Because I recognize that this is going to fit the formula that we saw at the very beginning of the formulas, which is a squared plus 2ab plus b squared. And I know that will factor as a square. It's going to factor as a plus b to the second power. And if I can get this to factor as a square, and this is a square, then I can factor that further using the a squared minus b squared formula. So if I can get it to look like this, then this formula applies, and that's going to let me factor this problem, right? So it's hard to see how that would all fit together without, like I said, without having been shown this first. I'm sure I didn't figure this out on my own. Somebody must have shown me how to do this kind of problem first, and then now that I know how to do it, it's not that bad. In order to get this formula to work here, we actually need to factor out a negative, right? So we'll factor out a negative. That's where the minus sign is going to come in. We'll get positive d squared plus 10d plus 25, and then this is going to fit into this formula. Instead of a, let me use a different color here. Instead of a, we're going to have d, right? So I'm going to make the same change over here. Instead of a, we'll have d, and instead of b, we're going to have 5, right? Because I have to rewrite 25 as 5 squared. So instead of b, I'm going to have 5. So I make that change over here. Instead of b, I'll have 5, and then that's going to get squared. Technically, you should check the middle term to make sure that 2 times a times b matches up to this, and it does, right? 2 times d times 5 is going to give me 10d. That's exactly what I have in the middle. So this formula definitely applies to this problem. So I can use this formula to factor it, and I'll get this result. So this is going to factor as d plus 5 squared. And now that I have it as a square, I can use this formula. Instead of a, I have c, right? So instead of a, I have c. I'm sorry, I don't know why it's not writing. And instead of b, I will have d plus 5, right? So it's a little bit tricky, but that's the substitution. Instead of b squared, I have d plus 5 squared. And instead of a squared, I have c squared. And so to factor this, I'm going to use this formula. Instead of a, I don't know why it keeps not writing for me. Instead of a, I'm going to have c plus, instead of b, I'm going to have d plus 5. And I'll do the same thing here. Instead of this a, I will have c minus, instead of this b, I'm going to have d plus 5. All right. So hopefully that's clear, the substitution that we're making. This is where a was. This is where b was, right? This is where a was here, and this is where b was. But we're changing out the a and the b for what's actually in my problem. Now we have to be careful with this minus sign because we want to subtract whatever b is equal to. In this case, b is equal to d plus 5. So we have to subtract all of those two terms. So we technically should use parentheses there, and then we have to distribute the minus sign. So it's a little detail that can cause you some trouble. So the first term, nothing interesting is going on. We just copy that down. But for the second term, I'm going to have c minus d minus 5 when I distribute that negative sign. And so this will be my final answer in factored form. So really tough problem. You really got to be prepared for it when you see this on the test, and it will be on the test. I've seen it every time. So make sure you're ready for it. All right. Hopefully we're getting close to the end here. So I think I only have 2 or 3 more problems. So if you stuck with me this far, good. Congratulations, because I know it wasn't easy. All right. So here we're solving equations. So notice the equal sign. That kind of changes the thing we're trying to accomplish here. I want to find the solution to this equation. Because it's c squared, that makes this a quadratic equation. And to solve a quadratic equation, we can't do this equation the same way we've done previous equations. I can't just get c by itself. Because I have c in 2 different places, I can't just get c equals from that. Because it's stuck, they're not like terms. I can't combine them together to just get 1 c out of those 2 c's. And so I have to find a different way to solve it. So the method we're going to use, it's kind of a workaround, but it gets us the solution. The first thing you have to do is get 0 on one side of the equation. So get 0 on one side. The second thing you have to do is factor. Factor the other side of the equation. Then you set each factor equal to 0. Equal to 0. And then you solve, and then you should be able to get c by itself, right? So let me go ahead and erase this here. So this isn't going to work. We can't just solve it for c. We have to do this workaround instead. So first thing, we got to get 0 on one side. So I'm going to subtract the 18 back to the left-hand side. So we get c squared plus 7c minus 18 equals 0. Then that's step 1. Step 2 is we're going to factor this just like we were doing earlier in the test. we need two numbers. I'm not going to write out all the details. I'm just going to verbally go through it. We need two numbers that multiply to negative 18, add to positive 7. And we can use the shortcut here because a is equal to 1. So once I find those two numbers, those are the two numbers that are going to go in my two factors. So it'll be c here and c here. So two numbers that multiply to negative 18, add to positive 7 is going to be positive 9 and negative 2. So I write those two numbers in these two factors. All right, so that's step 2, factoring it. Step 3 is set each factor equal to 0. So I'm going to take each of these factors, set each one equal to 0 individually. So we'll have c plus 9 equals 0 and c minus 2 equals 0. So that's step 3. And now step 4 is go ahead and solve each of these factors. And now that it's not c squared anymore, we can solve these in the usual way. We'll just get c by itself, in this case by subtracting 9 from both sides. So we get c is equal to negative 9. Sorry, that time I know I pushed the erase button by accident. And here we'll add 2 to both sides, and we get c is equal to 2. All right, so those are my two solutions. All right, do the same thing on this example. Oh, this is a tough one. Okay, we got 2 more. This one's tough because the numbers are big. Right, step 1's already done for us because it's equal to 0. Right, so we already have it equal to 0. Step 2 is to factor this. And a is not equal to 1 here, so we have to do the AC method. So a times c is going to be 20 times 18, unfortunately, which is going to be 360, which is tough. That's a big number, right? And then b is equal to negative 39. Sorry, it's a funny looking b. All right, so I need two numbers that multiply to 360 but add to negative 39. And oh, that's a tough one. I can't think of what it is off the top of my head, but I'm not wanting to list them all out again like we did earlier. Again, that's a method of last resort, which sometimes we'll just have to do. But I'm hoping to avoid that here. So I'm really trying to think what it could be off the top of my head. So sometimes what I'll do, this is a little trick that I use sometimes. I don't usually show this to my students, but sometimes what I'll do is go back to these numbers, 20 and 18, split them up in a different way, like let's say 5 and 4 here and 9 and 2 here, and then recombine to see if I can get 39 from these numbers. So for example, I could do 9 and 5, which would give me 45, and 8 and 2, which would give me 8, sorry, 4 and 2, which would give me 8. That would multiply to 360 also, but that still doesn't add to 39. And I was thinking the other way, 4 and 9 would give me 36, 5 and 2 would give me 10, but that still doesn't give me 39. So these numbers aren't really working for me. Maybe I could do 10 and 2 here, and 6 and 3. That's another way you could split up 18. And so that would give me 30 and 12, which doesn't give me 39. I could also do 60 and 6. That doesn't give me 39. So maybe let's try 5 and 4 with 6 and 3. So that gives me 24 and 15. I think that works. All right. So 24 and 15, right? So again, I'm using this pair of numbers with this pair of numbers and then just rearranging the order, like repairing them, right? And so I put the 4 with the 6, that's how I got the 24. The 5 with the 3, that's how I got 15. And those two do add to 39. Except we'll want them both to be negative to get negative 39, right? So this is another trick I will use. It takes a little practice to get the hang of. If that doesn't make sense to you, just go back to making a list. What multiplies to 360? 1 times 360, 2 times 180, and just keep going. Eventually, you'll have 15 and 24 on your list, right? Now, after all of that work finding those two numbers, I'm still not ready to know what the factor is because what I have to do is rewrite the middle term using these two numbers. So I'm not even done factoring yet. We have negative 24r minus 15r, right? So I rewrite negative 39 as negative 24 minus 15. This will be 20r squared still as the first term and 18 as the second term. I don't know why it's not cooperating. I guess my hand's getting tired probably. And this is 20r squared, right? And then we do the factor by grouping, right? So I'll group the first two terms together, 20r squared minus 24r, that's my first group, plus, and then negative 15r plus 18 is my second group, right? So this is supposed to be an 18 here. I'm sorry if that's hard to see. and then go through the factor by grouping process, right? So we'll factor out the common factor here, which will be 4r. That leaves me with 5r minus 6. Here I'll factor out a negative with the common factor, which will be 3, and that will leave me with 5r minus 6 when I factor out the negative sign. And then I can factor out the 5r minus 6. And that leaves me with 4r minus 3. So now this is factored. So that's step 2 is factoring it. Step 3 is to set each factor equal to 0. So we're going to get 5r minus 6 equals 0, 4r minus 3 equals 0. Oh, I'm sorry, that really didn't come out very nice. Let's try that again. Equals 0. And then we solve each of these for r. And so I'll do that over here where I have a little bit more room. I don't have much, but I'll just do that over here. So here I'm going to add 6 to both sides to solve this for r. So I'm going to get 5r equals 6. And then I'll divide by 5 on both sides. And I think this something's kind of getting laggy here, so maybe maybe my video's gone on too long, or maybe I have too many pages on this software that I'm using. So here, we'll add 3 to both sides. See, I don't know why it's not keeping up with me here, so let's try that again. We'll add 3 to both sides, and we'll get 4r, oh gosh, it's not keeping up, equals 3. Maybe I should slow down a little bit. And then we'll divide by 4 on both sides. And we'll get r is equal to 3/4. So that would be my other solution. All right. Whew. So sorry this took a little bit longer than my usual videos. Got one more to go if it's going to let me get through it. So again, step 1, get 0 on one side. So I'll subtract the 32w to the left-hand side. And so I'll have 8w to the 3rd power minus 32w equals 0. Got to get it equal to 0 first. Then we'll factor, and I'll start by factoring out the greatest common factor, which will be 8w, and that's going to leave me with a w squared minus 4. So here's that a squared minus b squared formula again. This part is going to factor even further as w plus 2 times w minus 2, right? So instead of a, we have w. Instead of b, we have 2, right? Because 4 is 2 squared. So instead of b, we have 2. And this 8w copies down. So that's how it factors. Then we set each factor equal to 0. So we'll have 8w equals 0. We'll have w plus 2 equals 0. And we'll have w minus 2 equals 0. And then you solve for w in each case. So here we'll divide by 8 on both sides. But this will still be w equals 0. So that'll be my first solution. Here we subtract 2 from both sides, we get w is equal to negative 2. And here we add 2 to both sides, and we get w is equal to positive 2. So this one has 3 solutions, which is what makes this problem unique from the other 2. Whew, okay, so that is your Chapter 4 practice exam review.